everybody, and welcome to Dumb Engineering. My name's Justin Dumb, and I'm joined by my friend and coworker, Anthony Gioia, and today we're going to talk to you about PLCs. So Anthony, thank you for coming on the show.
Thank you for having me, Justin.
So first off, what is a PLC?
PLC stands for Programmable Logic Controller, and at a very high level, it's the brains behind machinery in a manufacturing environment.
So what exactly does a PLC do in terms of functions?
So a PLC takes in information from a machine. It does some type of reasoning, decision-making calculations based on that information, and then it sends signals out to other components to control them, to position them, to turn them on and off. And that's basically how it works.
So you'd say that we were looking at inputs, taking in inputs, doing something mathematically with them, and then outputting based on that information. So 3 functions?
Mm-hmm. Yeah, so that's typically how you control a machine with a PLC.
Okay. So what are these types of inputs and outputs? What are the data structures?
So when working with hardwired inputs and outputs, there are 2 basic types. There are digital and analog. Digital is either a 1 or a 0, it's on or it's off. So things we think of that typically work that way are a push button or a light. And then there's also analog, which is a numerical variable, and it has units. So it's somewhere between a minimum or a maximum number, and then it is a meaningful number that doesn't just mean it's on or it's off. So an example of that would be a temperature sensor, where we would read that it's 80 degrees Fahrenheit, or a pressure sensor where you would be reading a number in PSI, as an example.
All right. So what type of operations do we have inside the PLC that allows us to do the thinking?
So there's an incredible amount of operations that you can use within a PLC. There's your basic mathematical ones. It's actually, you break this up into digital and analog again. For digital, you're using Boolean logic, if you're familiar with that, ands and ors. If you are doing analog, then you can do mathematical operations, comparisons, and there's so many different types of operations that you could use that it would be tough to cover them in the length of this video.
So we're not going to cover this today, but with communications, do these generally have other forms of communications, like other protocols that they can talk with field devices, or such as a drive to transmit information?
Yes, so typically PLCs also can communicate via their ports that they have on them. A standard port that a PLC has is an Ethernet port. Basically, it sends packets of data to and from a device that it wants to communicate with all over one wire, instead of having many, many different individual signal wires.
Okay, cool. So I see you brought us a demo today. Want to explain how it works?
Sure. Just to explain how, a PLC can do more than just your standard turning on and off of a light. Like if we had a light switch, we would just be flicking it on and this light would be coming on. But instead we use some timers. When I press in the light and hold it for 4 seconds, then the LED comes on. So it's just a simple example of how you use a timer function in a PLC.
So what happens if you just press the button and let it go? Nothing happens?
Nothing happens, because it's waiting and holding for you to hold the button for 4 seconds.
So after you press the button and then it starts counting, and then it will energize the output?
Yes, exactly.
All right, really cool. Well, thank you very much for coming on the show and helping explain PLCs.
Thank you for having me on, Justin.
Thanks for watching, and please stay tuned for the next episode of Dumb Engineering.
I'm Anthony Gioia, he's Justin Dumb, and don't stick your fingers in the circuitry.